Welcome to Formula 1 Maths. This is lesson 1.2, GCE A-Level, Further Maths, Applied, Year 1. In this lesson, we are going to learn how to use the principle of conservation of momentum to solve problems involving collisions. Newton's third law of motion states that to every action, there is an equal and opposite reaction. It can also simply be stated as action and reaction are equal and opposite. So according to Newton's third law of motion, when two bodies collide, they exert an equal and opposite force on each other. During the collision, the bodies will be in contact for the same amount of time. This implies that the bodies will exert the same magnitude of impulse on each other, but they will be in opposite directions. Because, as we've seen from lesson 1.1, I, which is impulse, is defined as force times time. So now, let's consider two particles, A and B, with masses m1 and m2 respectively, and also with initial velocities u1 and u2 respectively before collision, and velocities v1 and v2 respectively after collision. Then you have an initial situation like this, where A has a mass of m1 and an initial velocity of u1, and B has a mass of m2 and an initial velocity of u2. If we then let I1 be the impulse of A on B and I2 the impulse of B on A, then we have a final situation like this, showing the directions of the respective impulse on the particles. I'm going to reproduce this same illustration on the next slide to use it to derive a very important equation. So here we have this illustration here. Now let's consider the impulse momentum principle. I1 is equal to m1 times v1 minus m1 times u1, and I2 is equal to m2 times v2 minus m2 times u2. If we then take this direction to be positive, then according to Newton's third law of motion, and take into consideration the directions of the various impulses, we have I1 equals to minus I2. We can substitute these equations here, these two equations in here to get this, then expand the brackets to get this. We can now rearrange to get this. And this equation here is called the principle of conservation of momentum. And this says that the total momentum before impact is equal to the total momentum after impact in a collision. We are going to use this equation here together with the impulse momentum principle to solve questions. Question 1. Two particles, P and Q, of masses 3 kilograms and 5 kilograms respectively, are moving towards each other in opposite directions along the same straight line on the smooth horizontal plane. The particles collide. Before the collision, the speeds of P and Q are 4 meters per second and 3 meters per second respectively. After the collision, the direction of motion of P is reversed and its speed is 3 meters per second. Find A, the speed and direction of Q after the collision. B, the magnitude of the impulse given by P to Q in the collision. So we start by doing a sketch like this. Then we choose a direction. If we take this direction to be positive, we can then go and apply the principle of conservation of momentum, which is this one here. We'll do our substitution for the various values and we get this. So here we have 3 times 4 minus 5 times 3 because of the direction is equal to minus 3 times 3 again because of the direction plus 5v. Then we simplify to get this, simplify further to get 5v is equal to 6. Then we solve to get 1.2 meters per second. But we need to state that direction of Q after collision. As you can see, the value of this is positive. And we know that the positive direction is that way. But initially, Q was moving in this direction. So we go and conclude and say the direction of motion of Q is reversed by the collision. For B, we use the impulse momentum principle. We're going to choose one of the particles and use it to calculate our impulse. It doesn't matter which one you choose because we are looking for the magnitude of the impulse. As an exam technique, I will avoid using a value that I've calculated in the previous question. I'll use a value that is already given in the question. So I'll use P. So using P, we can do this substitution here. I is equals to 3, which is a mass, times the velocity, which has a direction that way, so it's negative, minus 3 again the mass, and 4, which was positive. So we simplify to get minus 9 minus 12, and then that would be minus 21 Newton second. And because we want a magnitude, we just take the value for the impulse of P on Q is 21 Newton second. Question 2. Two particles, A and B, of masses m and km, respectively, are moving towards each other in opposite directions along the same straight line on a smooth horizontal plane. The particles collide. Before the collision, the speed of A and B are 4u and 2u, respectively. After the collision, the direction of motion of both particles is reversed, and the speed of each particle is halved. A. Find the value of k. B. Find in terms of m and u the magnitude of the impulse given by A to B in the collision. So we start with a sketch once again, and this is the situation. Make sure you get the directions right, and then choose a direction. So we take this direction to be positive. Then, taking into consideration the respective directions, we can do our substitution and get this. We can now simplify to get 4mu minus 2kmu equals to minus 2mu plus kmu. Now, because you're looking for k, you need to bring the k's together, collect like terms, and we can get that. Simplify, we get 6mu equals to 3kmu. You can now cross out the m's, or divide both sides by m to get 3k is equal to 6. And then when you solve that, you're going to get k is equal to 2. So k is 2. For B, again, we use the impulse momentum principle. Do the appropriate substitution using, in this case, the values for A. We are going to get m times minus 2u, because this is in the opposite direction, minus m times 4u. Simplify to get this, and then you're going to get minus 6mu. We are looking for the magnitude, so we're going to state that the magnitude is 6mu. That's question 2. Question 3. Two particles, P and Q, are moving in the same direction along the same straight line on a smooth horizontal surface. The particles collide. Before the collision, the speed of Q is 2.5 meters per second. After the collision, the direction of both particles is unchanged, and the speed of P is 3.5 meters per second, and the speed of Q is 4 meters per second. Given that the mass of P is 2 times the mass of Q, A. Find the speed of P before collision. B. Given that the magnitude of the impulse on P in the collision is 9 Newton seconds. Find the mass of P. So let's do our sketch once again and put in the various values given. Now we have represented this velocity as u because it's unknown, and that's what you're looking for. And again, taking this direction to be positive and applying the principle of conservation of momentum, we're going to get this here. 2m times u plus m times 2.5 is equal to 2m times 3.5 plus m times 4. Simplify to get that, simplify further, and dividing everything by m, you get 2u plus 2.5 is equal to 11. Solve the equation, and you're going to get 4.25 meters per second. And that is the initial speed of P. For B, again, we go to use the impulse momentum principle. We are told that the magnitude of the impulse on P in the collision is this. So the impulse on P is due to Q. So this time I'm going to use the values for Q and do the substitution. I'm going to get 9, which is the impulse given, equals to m times 4 minus m times 2.5. So I'm going to get 9 is equals to 1.5 m, and then if I solve that, I'll get 6 kilograms. And this is the end of lesson 1.2. Thank you for watching, and I'll see you in the next video.